This is a tutorial for the thin film interference soap rings Newton rings simulation on my website. It starts off with a light wave you can see coming from the top and hitting this thin film here in the center with the gray. You can adjust the wavelength of it to whatever color you like. You will see that it does shrink in wavelength when it actually enters the film and slows down. You can also adjust the index of refraction of the thin film interference, which you can also see actually changes the change in the wavelength inside the film. You can also change the thickness of the film, if you like. And you can also change the thickness of the other media. So you could change this situation between whether the first wave is going to be upright if it starts in a denser medium, or if the first wave is going to be inverted if it starts in a less dense medium. So you can play around with all the phase shifts at each boundary. And here's what it's showing you on the right. So the first wave to reflect off of the boundary, that's wave number one. And in order to make them all separately visible, I shifted them over here. So you can see it's telling us it's inverted, because if we go over here, N1 is lower than N2. So we're going to have that fixed end reflection. It's going to invert the wave. And we can slow it down to see that a peak on the right side is corresponding to a reflected peak on the left side. So the second wave 2 here is the wave that's reflecting off of the second boundary. And again, you can control whether that's going to be upright by making the third material have a lower index of refraction, or you can make it inverted by having an even higher index of refraction on the other side. So we'll go back to that. And the net wave here is showing, of course, the net reflected wave. And we can see here that the first reflected wave that's inverted is actually in phase with the second reflected wave that was upright, provided that the thickness is 1.25 times the wavelength inside the film. And you can adjust the thickness. Now, the thickness you can actually adjust to be any amount. And you can see as I'm going through, if you watch the screen on the right, you can see the which represents the reflected light. You can see it'll be darker or brighter depending on the amount of interference. But if you want to stick to those half wave intervals that the worksheets usually do, you can click on snap to 0.25, and then you can show, if the thickness is a quarter of a wavelength, then they're going to be in phase for the reflected light, and if it's a half a wavelength, they'll be out of phase. So you can just stick to those snaps as you go. If you want all three or these two ways to be overlapped, you can actually click overlap, and it actually overlaps really everything. All three of these put together. It's not particularly useful, but I did put it there just so you can see how it might look in real life. But of course, in real life, this reflected wave would also be overlapped with the original incoming wave. So I usually don't do that. Auto thick is a feature I added just so that you could see the thickness kind of change up and down on its own and see that it would make the light pass in and out of phase. So deselecting all these, if you click on soap ring, this is now representing a soap ring seen head on, and then on the side it's the soap ring seen from the side. You can see because of gravity it gets thicker as you go down, so that of course changes the thin film interference pattern that you see. And if you adjust the wavelength, you can see how it would change for different colors. And if you adjust the relative thickness, you can see how that would change the width of the bands in the interference pattern, like that. If you click on white light, this is superimposing the interference fringes from red, green, and blue simultaneously. And this is perhaps how it would look if you used just shined white light on maybe a soap bubble, for example, if you've ever done that in your physics classroom. It kind of looks like that. And the bands, of course, get thinner as you go down because of the larger multiples of wavelength of the thin film. If you click on Newton's rings, this is, I guess a half convex lens. And so you're seeing it head on here, and then, of course, you're seeing it from the side here, and you can see the same dependence on the wavelength or how it changes with different thicknesses. And similarly, you can also click on white light and see that interference pattern. And when you're ready to go back to the main part of the simulation, you can just click on Soap Ring again and you'll be back here. So I hope you find this useful for your teaching.